how to control.
Okay. So let's kind of walk through our outline today. I want to give you kind of an idea of what we're going to go through. And we're not doing too much. We're in the fourth section, section 1.4. It's going to be based on angles today. Angles. You probably know about angles. You probably learned about them in general math days, junior high days, but there's lots of little weird stuff you do need to know. So we're going to talk about some vocab terms, obviously. Got a lot of vocabulary. There we go. Almost full up. Got a bunch of vocab terms that we need to discuss. The second thing we're going to talk about is the different classifications of them. Classifications of angles. How many different types of angles there are. There's actually 5 types. Most people don't know that there is 5. Most people think 4, but yeah, classifications. Next type, or the next one we're going to talk about, is we're going to look at how to draw them. Now I know this seems silly, you should probably already know how to draw angles, but there's this thing that will guarantee that everyone in this room will draw the exact same looking picture, and it is called standard position. It's this concept that it will alleviate, the pressure from if I ask you to draw a certain type of angle, that it's not just all over the place in your paper. You're facing the same direction as everyone else in the room. We'll eventually get to that. It'll tie into some of the stuff we've previously discussed. So there's lots of little things we'll do here. And then the last stuff we'll do is we'll talk about measurements and degrees and all that good stuff. So we are going to measure after this point. So, okay, questions on our kind of our basic outline of what we're doing today. Okay, so let's talk about vocab. Let's do our definition. So, an angle. Definition. Okay, an angle is formed by the intersection of 2 angles at a common endpoint called a vertex. You'll get that now. There's your definition. Intersection of 2 rays at a common endpoint. 2 angles, whatever I write. I said rays and I wrote angles. Get this image hour in here. 2 rays at a common endpoint, sorry. I don't know why I wrote angles again. Okay, so here's my question. I know this will be your story. What is a ray? What does it look like? Talk about it a couple days ago, please.
There's one endpoint with an arrow going.
Yeah, there you go. So you got one endpoint. You got an arrow going one. Okay? That's a ray. Well, this thing says we have 2, and they're intersecting at a common endpoint. So we're going to have them touch at their endpoints. So we're going to have another ray going off of it. There's your angle right there. That's it. 2 rays connected at the endpoint. Now, they even said the endpoint has a specific name. It is called a vertex. The vertex is the most important spot on an angle. So let me label it. This is the vertex. Everything comes down to knowing what the vertex is. So when we start naming angles, the vertex is the most important thing you need to know. Right where those endpoints sit. All right, questions on the drawing. Most people know what angles are. You've probably seen them since junior high days, or even middle school. All right, now, a couple more vocab terms we need to know. Number 1, the rays. The rays have specific names. I know it seems weird, you probably have never learned that. It is called the initial ray and the terminal ray. That's really creepy. terminal ray, initial ray. Now, before somebody asks, yes, it doesn't matter which one's which. I'll explain that later. That naming system will make sense when we start drawing, so you know which one is which, like which one's the initial, which one's the terminal. Initial means starting, terminal means ending. All right, questions right now on the basic definition and what it looks like. Okay, so now, let's get to the naming system before we get to the classifications and how to measure them and how to draw them accurately. The naming system, there's a ton of different ways you can name angles, tons, like endless. But it comes down to whether you're just kind of paying attention to it. So what I'd like to do, if you have your angle, let's draw another angle around it. You can draw it differently, I don't really care. Right now, we haven't learned how to draw them accurately, so here we go. Here's my angle. Let's give it some different points on it. So let's call this, I'm going to give some different points. Let's call this A, a B at the vertex, and we'll call C. So put B at the vertex on this one. Okay, now what we're going to try to do here is try to name it, the notation. So if you had to name a certain angle that fit a certain spot on the paper, had a certain degree, an angle to it. Degree is how we measure. We need to learn how to name it. This is the name of an angle. Easiest way to do it, if you want to name that angle, what is the vertex letter? B, that's how you can name it. It is literally called angle B. You can put a little mock angle symbol and then put the capital letter behind it. And we just say angle B. That's the easiest way in the world. And you're probably thinking, well, why do we need another one? Because you agree that that picture I've drawn is super simple looking. Easy, it's one angle, right? But the minute we start drawing angles off of it and they're going every which way, now you got to get more specific. Because if you just said angle B, I have no idea what angle you're talking about. You have to be super specific. So the more specific ways to write it is use the three-letter system, kind of like a plane. Use a three-letter system. You have to name one dot that's on one of the rays. Then you have to, the second letter you pick has to be the vertex. The third letter has to be the other ray. So, can somebody name that angle right there?
Angle CBA.
There you go. So you could call it angle CBA. You pick one of the dots on one of the rays. The vertex has to be the second letter, and the third letter has to be on the other ray. Now, it doesn't matter if there's a ton of different points there. So if you had an angle that had dots everywhere, pick one ray, the vertex, and the other ray. That's all you have to do. So if you have a bunch of letters, you could have an angle that's named 20 different things, but it means the same picture. So let me put an example here. Another picture, let's go with this angle. And let's give it a ton of different letters. Let's call this M, N, O, P, Q, R, S. So you have a bunch of different dots all over the place. What's one way you can name this? Easiest way you can name it. Angle P. It's a simple picture. You can call it angle P. There's no other weird angles coming off of it. Now, if you're going to go the three-letter system, pick one of the letters on one of the rays. Which ray do you want? You have a bunch of options. You can name one letter.
S.
S. Okay, we're going to start with S. So we name S. You have to pick the vertex now, which is P, and now pick the other ray. Any dot there.
N.
N. Boom, there's an A.
Boom.
You could call it angle MPQ for all I care. One of the rays, the vertex, the other ray. Does that make sense now, the system? I prefer the three-letter system. Start practicing it so you get good at it, right? One ray, the vertex, the other ray. Now, if there's multiple angles coming off, this will save you so you know which one you're talking about. The book will get kind of cheeky, and they're going to start doing things like this where they put numbers on the inside. That's really nice if they do that, because that's another name you could call it. You could call this angle number 1. I like that. It's not This is not the measure of that angle. Like 1 degree, if you know what degrees are, 1 degree is like really small. That is not a 1 degree angle. That's the name of your angle itself. So the reason why that's nice is if you have like 20 different angles going on in the picture, you can just pick out the one by number. Okay, questions with the naming system. Perfect. All right, let's talk about the classifications. Classifications is the next thing where I want to talk about, where we talk about the 5 different types. Now, the other thing that we haven't done is I haven't told you how to draw correctly, and we haven't talked about how to measure yet. So this, you just got to get used to the words that we use. Okay? All right. Questions with the naming system or anything I've done up to this point? Don't be afraid to fire it out there. Everyone's good so far? Okay. Pretty straightforward. All right. Let's talk about the classifications. Types. All right, can't spell today. Classifications. All right, so number 1, first type, the smallest type of angle we have. It's called acute. Bless you. Acute angles, the best way I can explain to you, acute angles are anything between 0 degrees up to 90 degrees. But it's between there. It's between 0 and 90. So 42, 35. Pretty much every picture I've drawn today has been acute. These are all very small angles, very tiny. So that's acute. Now, I know it's going to seem dumb. The way I remember acute is I think of a cute puppy, right? Puppies are small and cute. Acute, right? Small. I know it's dumb. It helps you remember. Second type. Anyone happen to know the second type? A right angle. Yeah. A right angle. Exactly 90 degrees. Exactly 90. So the acute has been all the angles I've picked up to this point, all those drawings I've done. But a right angle, what should it look like? An L shape, a perfect L. Now, what do you put in the little like area of that right angle?
Square.
A little square, right? Okay, a little box. Do you happen to know why you put that there? Okay, I agree. It's to show that it's 90. You have to put that little box there. But why? I agree with that, right? They use it to denote that it is 90. But why did they start marking that in the first place? That's the question. Say it again. Sure it is on what? No, not quite. You're on to something, but I'll get back to it. It's weird. No one really knows. Most people are like, well, it looks like a square, right? The squares have 90s, or it looks like a box, or they put it there. But no one actually knows where it came from originally. Here's why. Here's this stuff. Coordinate plane, right? Talk about coordinate plane. I'm going to draw a 90-degree angle in the plane. Put the dot right on the origin. I'm going to use the x-axis and y-axis. Do you agree that that's a 90-degree angle? L and y-axis. Or sorry, x and y-axis. That's why. It's the 1x1 box that's right from the x and the y-axis. That's exactly why they put box there. Because it's denoting where it would sit on the actual coordinate plane. You're actually hitting both axes. So that 1x1 box would fit in that location. Most people forget that. They don't even know. But right angles. We'll come back to that one later. We'll come back to that drawing later. What are we on? Third type.
Twos.
Third type. So twos. Obtuse. Anything between 90 degrees up to 180. Everything between those, 92 degrees, 134 degrees, 178 degrees between there. How I remember the word obtuse? I think of the word obese. Big. Obese is big. Obtuse is big. So, this is an obtuse angle. Big. Bigger than an L shape. Now, obviously, all these numbers I'm coming up with, these are the degrees. That's how you measure angles. Okay, questions on the main three. Most people know those. Most people. Once you see them, like, oh yeah, I remember hearing about those in like elementary days. Fourth type. What is my fourth type?
Straight.
Straight. Nice. Straight. What is a straight angle? Exactly 180. Exactly 180. What would it look like? A line, right? Why do you think they call lines straight lines? Because it's a straight angle. That's actually why they call it that. Most people always just hear, oh, it's a straight line. Because they think straight means like the line you're drawing. The straight means you're making a 180 degree angle with it. That's what straight actually means in that term. Right? So, 180 degrees, it actually looks like a line. I agree with that. Or it looks like opposite rays. Rays that are facing the opposite direction. So it makes a perfect line. So 180. Now, the fifth type. The one that most people don't know. Most people, I'm not saying it. It starts with an R. What? Do you have a guess? What kind? Okay, right. I'm looking for a guess. I've had it in the past. People have actually known it. Starts with an R. R-E? R-E-F? Oh, somebody said reflex. Reflex.
Oh, right.
Nice. Most people don't know. Okay, there's a fifth type. It's called a reflex angle. It's anything when you go past 180, so you're past straight, but it's up to 360. So it's up to 360. A full 360 would be a full circle. It's just shy of that 359. So it's anything past that. Now, reflex angles, if you were to draw it, would look like this. So you draw your angle, you would use a little dash arrow to signify the way you're spinning, and then it would end up going like that direction. You went past straight. Now, why do they call it reflex? It's based on anatomy. Anatomy is the study of the body, right? The idea is that the best image I can give you is if you hold your arm out straight. Hold your arm out. Some people have the luxury, they're really flexible, they're double jointed, where you can have your arm go past straight. Some people have that luxury, like they're really flexible, like, oh, there's one Fry's got it. She's really flexible, right? She can do it. Sorry to put you on the spot, right? Flexibility is a good thing, right? You can actually have a lot of strength with flexibility. Like gymnasts, they have a ton of strength because they're super flexible, right? But here's the idea. Most people, like usually guys, not to be sexist, but normally guys have a different muscle structure, right? Most guys can't go past straight. Some guys can. They have that luxury of doing that. They're flexible. But some guys can't. When their arm goes past straight, when it's not meant to, it's called a hyperextension, right? A hyperextension is when you tear ligaments, okay? But past straight, it typically happens in football. You try to make a tackle, but you don't let it do placing arm hyperextension or leg hyperextend. And the idea is that the body's natural reaction is to reflex, to pull it back and crutch it, right? It's actually called the reflex angle because of that body's natural reaction when it goes past straight to reflex it back in, to pull it back, okay? It's one of those things. Sometimes your knee buckles. It's actually hyperextending, just a hair. It's not doing any damage. The reason why most guys have it, most guys have bigger biceps than women, and the ligaments can't go past the straight. Some girls have that, but some are usually flex. So, but these are my 5 types. Questions on the 5? Okay, here's the thing. I know this is gonna seem weird. If you have graph paper, if you still have that from the other day, bring out the graph paper. If you don't have graph paper, that's fine. You can just draw in your notes. Just draw kind of a box picture of your notes. Now, in theory, if you didn't use it for the homework or whatnot, you probably are in graph 3 or 4, somewhere in that ballpark. If you haven't used it at all, you're in graph number 1. But, I mean, some people don't. Not a big deal. All right, now here's the idea. What I'd like you to do is if you have some graph paper left, or if you don't, just draw this mock picture. I want you to put the vertex right on the origin, like I just did a little bit ago. So I want you to put the vertex right on the origin, and I want you to draw your first ray going along the x-axis. This is how you're going to draw an angle every single time, no matter whether the grid is behind it or not. So if you don't have grid paper, your picture better look like this. It's a dot, you're going to the right of it. Does that make sense? This will guarantee that everyone in this room will always draw the exact same picture, and I don't have to like turn your paper to see if you draw it correctly. You're always going to start to the right. Then you're going to open up counterclockwise. You're going to open up this direction, and you're going to draw that final ray, wherever it lands. So let's name this. So this is the angle, right? That's what I'm measuring. So obviously this is my vertex. We've talked about that already. That is the most important spot. That's how you name it. But the first ray that I drew along the x-axis, that one's called the initial ray. It's the starting ray. Your initial ray should always be the same ray every single time. The terminal spot, the terminal ray, the ray where you end at, is the ray where you're trying to measure to. Terminal. Does that make sense why you named it? Initial means starting, terminal is where you end. Now, this is something I hinted at earlier this week. Okay. Where's quadrant number 1? Right. Most people remember that. We've been talking about it all week. There's a reason. That's the first box you'd hit when you draw your angle. When you draw your angle and you open up counterclockwise, this would be the first box you'd actually hit, correct? You're seeing it right there. I just did it in front of you. If I kept opening, and I opened up my angle even further, so I didn't just stop here at this, I kept going until I went this way. What quadrant is that? 2 for a reason. Because that's the second box you hit when you draw angles in the same position. That's actually the reason why they number them counterclockwise. You're seeing it right there. That's why they do it. It's because of angles. So then this would be your quadrant number 3, where your reflex angles would start, and then they end over here in quadrant number 4. Most people never get to see that. They're just taught in algebra 1, 1, 2, 3, 4, but they never understand why. You're seeing it right there. Now, the only spot on the planet where you'd actually get a different number system is if you go over to Europe. Europe would teach it a little bit different. I've had a couple foreign exchange students in the past where their instructors teach them one is in the upper right corner, but then they go the other direction, or 2, 3, 4, because they draw their angles differently than we do. So there is a reason for that. It's a completely different topic. I understand why they're doing it. It's something we will talk about this year, but they're doing a different type of math than we are. Okay, when they talk about that. But this is our number system, how we do it. Does that make sense? The 1, 2, 3, 4 system. Okay. So that's the idea behind drawing. Now, what I'd like you to do, if you haven't already, go to another grid and draw a 90-degree angle. So if you have another graph that you have open that's free, let's draw a 90-degree angle here. So where's my initial ray going to be? X-axis, right? There's my x-axis. That's the initial. You got to start along the x-axis. And where's 90 going to be? Straight up. Okay, we know we're going to go along the y-axis. That's why the box is sitting there. This is a right angle. It's 90 degrees. And that's why they put the box next to it. There's a couple other terms I want you to know when we talk about right. So if you start reading them in the book, you understand why the book is suddenly using different words than I am. So we talk about right angles. 90 degrees. Here's the terms you need to be familiar with. Number one, the first word that your book will use a lot. Perpendicular. Perpendicular means 90 degrees. Typically why the book uses that, they'll talk about two objects, two lines, two segments, two rays that are perpendicular to each other. The lines themselves are perpendicular, so they're 90 degrees. It means the same thing. Okay, we're good with that. Second word. This is one that if you go to a college level calc, pre-calc, Calc 2, Calc 3, they're going to use the word orthogonal. Orthogonal. Why do they have a different word? Objects can be orthogonal to each other. Like a triangle and a square, they can suddenly touch at 90 degrees. They're orthogonal. The triangle is orthogonal to the rectangle. They're meeting at a 90-degree angle perfectly somehow. Lines can be perpendicular, but objects can be orthogonal. Means 90. Now, if you're in drafting, if you're in some type of fabrication, they might talk that it's flush. Means 90. You're in a perfect L shape. Perfect 90. Or they could just say that it's square. Oh, you're square. You're 90. You're good. Those are the terms you need to know. Questions at all about the vocab so far? Got one last topic, then we'll be done. We'll be done in 3 minutes. Let me start the camera. Okay, the last topic is this idea of what I've been hinting at, but I haven't even shown it. How do we measure? What object do we use to measure angles?
Oh,
Say it?
protractor.
Protractor. Yeah, we use a protractor. Well, most people, maybe you've seen one, maybe you even have one, maybe you still have one. I have no idea, so here's a protractor. Here's a protractor. Okay? You're going to get one of these on Monday. One of these. I give you one. You get to keep it. It is yours. Don't lose it. This cost me money. I paid personal money to have you have one of these, so you don't have to go buy one. It won't be in color. It will be just black and white, but it will look just like this. Now, why I put it on this? See-through, you can put it down on objects so you can measure angles. You can see the object behind you. Okay? This paper that I printed on is overhead sheets. It literally cost me $1.50 a sheet. Don't lose it. Okay? Now, this printed. So if you look at this and you can't read the numbers, right? You can't read the numbers. Turn it over. It's printed so you can read it. So on one side. Now, if you get it wet, you put it in your locker and you put a water bottle on it. It literally will be able to wipe the stuff off because it's printed on plastic. You'll be able to like smudge it off. So don't get this wet. And don't pick at it with your fingernail. It will literally peel off. Okay? Because it's printed right on plastic. So keep that in mind. Now, how you measure stuff with it. So let's say you had an angle on a piece of paper, right? So here's your angle. It's like that. Okay, it's an acute angle, right? It's smaller than 90. What you do is you take your protractor, you slide it to a spot where this dot right here, this little crosshair, is right here. Then you line up this wall, this part right here, with this initial side. So then your plastic piece is, it's doing this, and you can see the whole protractor like that. Okay? And once you have it lined up, this terminal side should be going somewhere, this direction, and you'll be able to read off the number. Now, some people have really poor vision. I understand that. It happens. So what you can do, since this is really hard plastic, it is like really thick stuff, you can use it as a straight edge, and you can extend, I can literally take this, put it on my paper, and use it to extend the walls like a straight edge, like a ruler. I can extend this further, and then I can see what numbers I'm actually hitting, in case you need to do that. Now, some people get so thrown off by that, they're like, Ward, you're changing your angle. Your angle's down here. That's where the angle sits. Where the vertex sits, that's where your angle is. I'm not changing an angle because I extended a wall further. The angle hasn't changed size. So it's still there. It's just now you're reading off a number. Now, when you read off these, you agree that this angle is acute. It's smaller than 90, right? So when you start rattling these off, you better use the inner track numbers. The number better be small. Don't tell me the angle is 130 when you can see that it's less than 90. Common sense tells you it's acute. Don't tell me it's 130. You have to use the inner track. That's why there's two sets. It depends on how your angle is drawn. Is it drawn to the left? Is it drawn to the right? You can put it either way, so you don't have to flip this thing over. You can just kind of put your angle down. Turn it so it matches. So if I was measuring this, what is that, 50 degrees? Okay, you gotta be exact. You're gonna be as close as you can, but within 1 degree. So if it's 51, tell me it's 51. Questions on how to measure. You're gonna get these on Monday. We're gonna do a bunch of measurements. Don't lose this. If you lose this, because I know it will happen, so you'll lose it. They'll put it in their book, it'll slide out, it's plastic. I use it as a bookmark. That's how I always remember it. If you lose it, guess what? You're gonna have to go to Target and buy yourself a new one. Or Walmart or something. You will need a protractor to measure stuff in here. So if you lose the one I give you, you have to go buy yourself one. Okay, questions at all? Perfect. Done for the day? Relax. Well, that stuff makes sense. It's a nice, clean intro day. Good.